welcome to the deep dive. You've sent over some really interesting research this time.
Yeah, it all seems to circle around how we learn, how we understand things.
Specifically thinking scientifically and maybe more fundamentally, our own personal beliefs about knowledge itself.
Exactly, what we think knowledge is and how we get it.
Okay, let's dive in. The mission today really is to unpack the big ideas from these sources on personal epistemology. That's the fancy term, right?
That's the one. How those beliefs develop, and importantly, how they shape our learning. Especially, it seems, in science.
Right. So it's not just about what you know, but digging into how you know it and what you believe about that whole knowing process.
Precisely. And we'll be looking at that interplay, that connection between these beliefs and how we actually, do learning, like engaging in scientific practices.
And how these beliefs aren't fixed. They can evolve.
Yeah, definitely. We'll explore how they change, maybe what triggers those changes, like bumping up against a totally new idea.
Okay. And the payoff for the listener is understanding this might make their own learning feel more meaningful, maybe more impactful.
That's the hope. Understanding the how of knowing can really change the what and why of learning.
All right, let's get started. This idea that our beliefs about knowledge change, that seems key. They aren't set in stone.
Absolutely fundamental. And some researchers, you mentioned King and Kitchener and Baxter, Magolda too, they point to something called cognitive disequilibrium.
Ah, yes, that feeling when things just don't quite add up, that mental friction.
Exactly. You hit something that clashes with your current understanding, and it sort of forces you to pause and reevaluate.
Like a mental itch you have to scratch.
Kind of, yeah. It makes you reconsider the whole picture, not just that one piece.
So for anyone listening, that uncomfortable feeling when a new idea challenges your view, that's actually productive.
Potentially very productive. It can be a real engine for growth if you lean into it, rather than just, pushing it away.
Okay. But is that the only way our beliefs change? That feeling of imbalance?
Well, not necessarily. Other folks, like Luca and his colleagues, they propose more contextual models.
Meaning
that while that disequilibrium can happen, it might not be essential. Change can also be more gradual, influenced by the specific situations we find ourselves in, sort of learning from context.
Okay, that makes sense too. Sometimes it's less of a sudden shock and more of a slow burn, maybe. Your thinking shifts subtly with experience.
Right. Now, closely related to that feeling of imbalance is another concept, epistemic doubt. Bendixson and Rule talk about this.
Epistemic doubt. So uncertainty about what you know or how reliable your way of knowing is.
Exactly that. That, maybe I don't have this quite right moment. Their model suggests this doubt can be a really potent trigger for examining your beliefs.
So again, for the listener, questioning what you thought you knew isn't necessarily bad. It could be the start of getting a stronger grasp on something.
It could be a vital first step, yeah. But the question then becomes, what do you do with that doubt?
Ah, right. Does it just sit there or?
Well, this is where Baxter Magolda brings in epistemic volition.
Volition, like will, effort.
Precisely. It's the conscious decision, the personal responsibility you take to do something about that doubt, to engage with it, explore it, maybe change your mind.
So it requires active effort. You can't just passively feel uncertain and expect your understanding to deepen.
Exactly. Change requires action. And even then, the sources remind us, it's not always a straight line forward.
What do you mean?
Well, even if you made progress, develop more sophisticated beliefs, slipping back into old, maybe more comfortable ways of thinking, that's still a real possibility.
Old habits die hard, even thinking habits.
They can, yeah. And part of this active process involves using resolution strategies.
Ways to deal with the doubt, essentially.
The mental tools you use to grapple with conflicting ideas or uncertainties, like maybe seeking out different perspectives or looking for more evidence.
Actively trying to resolve the tension.
Right. And Baxter Magolda talks about this, often involving encountering new assumptions, ideas you hadn't even considered, comparing them to your existing ones, and then potentially reshaping your beliefs.
Leading to, what did the research call it? Advanced epistemological beliefs.
Or sometimes self-authoring of knowledge, where you're really constructing your own understanding, taking ownership, not just relying on what others say.
Okay, so it's this dynamic, effortful process. Now, how does all this connect to actual learning, motivation, our feelings?
Yeah, that's a huge piece. Pintrich pointed out that we know personal epistemology is intertwined with learning, motivation, and affect our emotions, but figuring out the exact relationships. That's still very much an active area of research.
But there are models trying to map it out. I think Shamar-Akins had one.
Yes, her model tries to predict how beliefs about knowledge and beliefs about learning influence each other, and then how that combination impacts things like classroom performance or how good you are at managing your own learning, self-regulated learning.
Interesting. And Hofer, she had a different angle, right? Epistemic metacognition.
Right. Hofer reframes personal epistemology as epistemic metacognition, basically thinking about your own thinking regarding knowledge.
Like being aware of what you know, how you know it, and how reliable that knowledge feels.
Exactly. And she connects this self-awareness directly to everyday learning and our motivation, what actually drives us to learn stuff.
So being more aware of your own knowing process could make you a better, more motivated learner.
That's the idea. But, as Luca and others remind us, it's complex. The interplay between thinking, motivation, learning. It really depends on the specific situation, the context.
No simple formulas.
Not usually. And we can't ignore the emotional side either.
Right, you mentioned affect. Learning isn't always cold and rational.
Definitely not. Hofer and Pintrich, Mansfield and Clinchy, they've explored how emotions connect with our beliefs about knowledge. And Pintrich talked about the hot nature of learning our goals, beliefs, motivation. They're all mixed up together.
Like Alexander and Schutz and Davis also emphasized, that learning is situated, social, driven by more than just pure logic.
Precisely. If you care about something, if you're motivated, that changes how you engage with information and potentially how your beliefs about it evolve.
Okay, so we've talked about doubt and volition. What other conditions really push this epistemological change?
Well, dissonance is a big one we touched on earlier. King and Kitchener, Baxter, Magolda, they highlight when experience just doesn't match expectations.
That, wait, this isn't supposed to happen?
Exactly. That mismatch can really force you to reconsider your underlying beliefs about how things work.
Especially if it happens repeatedly or from different angles.
Baxter Magolda suggests that can be a strong catalyst, pushing you towards that more self-authored understanding.
And Bendixson and Rule added another condition.
Personal relevance. If the topic, the doubt, the new idea, if it feels like it actually matters to you, to your life, your goals, you're much more likely to invest the energy needed to grapple with it and potentially change your thinking.
Makes sense. If it feels abstract or irrelevant, why bother putting in the hard mental work?
Right. Now, we also need to factor in cognitive ability and the environment.
How do those play in?
Fisher's work is really interesting here. He kind of blended Piaget's ideas about developmental stages with Vygotsky's focus on the social context.
Okay, so nature and nurture interacting.
Pretty much. He talked about skill development as this interplay between our own cognitive horsepower, you could say, and the specific environment we're in.
It's not just internal potential, but how the environment supports or challenges it.
Exactly. He distinguished between our functional level, what we can typically do alone, and our optimal level, the best we can do alone under ideal conditions.
But we can sometimes go beyond that optimal level.
Yes, and this connects to Vygotsky's ideas. With the right environmental support or scaffolding from someone more knowledgeable, we can often perform above our unassisted optimal level.
Like a good teacher guiding you through a problem you couldn't solve alone.
Precisely. That support helps you reach higher. And Shamar-Akins also stresses that these external environmental forces definitely shape our overall epistemological belief system.
It's really a dynamic system, isn't it? Internal beliefs, external context, cognitive ability, all interacting.
Very much so. Which leads nicely into another concept, reciprocal causation.
Reciprocal, meaning it goes both ways.
Exactly. People like Dickens and Flynn and Harris, they argue the relationship between us and our environment isn't just one way. Our traits, our abilities, our beliefs, they influence the environments we encounter or create.
And those environments then shape us in return. A feedback loop.
Right. They even talk about a social multiplier effect.
Which is?
The idea that if you improve one person's cognitive environment, say, through better schooling, it doesn't just benefit them. It can have positive ripple effects on the people around them, boosting their cognitive environment, too.
Interesting. So improvements can spread through a social network.
That's the theory. And Shamar-Akins suggests a similar feedback loop within learning itself. Your performance in class, how well you manage your own study habits, that can feed back over time and actually revise your underlying beliefs about knowledge.
That's quite optimistic, especially thinking about, wasn't there a concern raised about how common, sophisticated, or evaluativist thinking is in adults?
Yes. Kuhn and Weinstock noted it's perhaps less common than we might hope. But this idea of reciprocal causation offers a potential pathway. Maybe we can create environments and interactions that kickstart a positive cycle of epistemic development more broadly.
By understanding these feedback loops better, we might design learning experiences that foster that deeper thinking about knowledge.
That's the potential, yes.
Okay, let's pivot slightly now. How does all this theory about personal beliefs play out specifically when people are learning science?
A really important application. The sources stress a big shift in science education thinking.
Away from just memorizing facts.
Exactly. Towards actually using scientific ideas to make sense of the world. People like Duschel, Lehrer, and Schauble, Berland and her group, they're all pushing for this.
It's about understanding why science works the way it does, not just what it says.
Right. Ford calls it developing a grasp of practice. It's not enough to just follow the steps in an experiment. You need to understand the purpose, the reasoning, the epistemic goals behind those scientific actions.
Knowing the why behind the what. So not just pipetting because the instructions say so, but knowing why that step is needed for the experiment's logic.
Precisely. And Berland and her colleagues developed a framework to look closely at this. They call it Epistemologies in Practice, or EIP.
EIP. Okay, what does that help us see?
It helps characterize how students are engaging. What are their goals in terms of building knowledge? What are their understandings about how you actually do that effectively in science?
So it gets beyond just the right or wrong answer to the thinking behind the answer.
Exactly. And their framework highlights 4 key epistemic considerations when building scientific knowledge.
All right, let's break those down. First one.
The nature of knowledge products. Basically, what kind of knowledge are we trying to create here?
Like just describing something versus explaining how it works?
Yes. Is it descriptive, the leaves turn brown, or mechanistic? The lack of chlorophyll due to seasonal changes caused the leaves to lose their green pigment, revealing underlying brown pigments. Science often pushes towards those mechanistic explanations, the how and why.
Got it. Okay, second consideration.
Generality. How does this new piece of knowledge fit with other things we know? Does it explain just this one specific case, or can it apply more broadly to a range of related situations?
So connecting the specific experiment or observation back to bigger scientific ideas.
Exactly. Seeing how a specific finding illustrates or refines a general principle.
Makes sense. Third one.
Justification. This is huge in science. How do we support our claims? What's the evidence?
Right, you can't just say something is true.
No. It's about actively interpreting data from experiments, from existing theories, maybe even from experience, and using it to build a logical case, to justify your explanation or model.
Moving beyond just presenting data to actually using it as evidence in an argument.
Precisely. And the fourth consideration.
Audience. That seems maybe less science-y.
You might think so initially, but it's crucial. Audience is about considering who you're building this knowledge for. Your peers, your teacher, a wider community.
And how does that change things?
It affects how you communicate it. Obviously, clarity matters. But it also influences how you anticipate potential disagreements, how you might address alternative ideas, how you collaborate to build shared understanding. Persuading others is a key part of science.
Okay. If I have to convince you of my explanation, I need to think about what evidence you'd find convincing, what questions you might ask.
Exactly. So these 4, nature of knowledge, generality, justification, and audience, are lenses for looking at how people engage epistemically in science.
Now, the sources talk about meaningful engagement. How does that connect to these 4 ideas?
Meaningful use, according to Berland and her team, happens when students see these epistemic ideas, justification, generality, etc., not just as rules to follow for the assignment.
Like ticking boxes on a rubric.
Right. Not just that, but when they see them as actual intellectual tools that help them achieve their own goals of understanding the science better.
So using evidence because you genuinely want to build a strong case, not just because the teacher told you to include data.
Exactly. And for that to happen, the goals of the classroom need to align with the broader goals of science, which is fundamentally about making sense of the natural world. Students need to adopt those sense-making goals themselves.
The research had some examples of this, right? Like the 5th graders with the condensation model.
Yes, that was a great one. They were debating whether to draw a specific pop can or a more general liquid container.
Okay. Why did that matter?
Because their discussion wasn't just about drawing. It was about the model's flexibility, its generality. Could it explain condensation on any cold surface, not just this one can? And they saw that generality as key to convincing others that the water came from the air, not leaking from the can.
Ah, so they were using the idea of generality and audience as tools to make a better scientific argument. Their goal was sense-making and persuasion.
Precisely. Not just task completion. Then there was the ecosystem simulation example.
With Gretchen and Daniel.
Right. They were using data from the simulation, but not just reporting it. They were using it to justify claims about what an invasive species was eating.
And refining their explanation.
Yes, refining the mechanistic explanations for why populations were changing. Daniel asking why the invader survived if it ate the same grass as the rabbits. That's pushing for a deeper causal understanding, using evidence from the simulation.
They were genuinely trying to figure out the how and why using the data.
And the last example, the student, Seema revising her condensation model.
What drove her revision?
Her audience and justification. She wanted to make her explanation more convincing. So she added information about humidity levels, specifically to counter the alternative idea that the water might be leaking.
She was anticipating skepticism and using evidence strategically to strengthen her justification for a specific audience.
Exactly. In all these cases, the students' actions were driven by trying to make sense of the phenomenon, not just follow instructions. They were using epistemic ideas meaningfully.
That really clarifies the difference between just doing science activities and genuinely engaging in scientific thinking.
It does. And understanding this has implications beyond the science classroom for all of us.
Absolutely. So, thinking about our listener, how can understanding their own personal epistemology and aiming for this meaningful use help in their day-to-day learning?
Well, first off, just knowing your beliefs about knowledge can change is liberating, right? It opens you up to new ideas.
Instead of feeling threatened by challenges to your views.
Exactly. And knowing that things like dissonance or personal relevance can trigger change helps you maybe lean into those moments, see them as opportunities.
Recognizing that uncomfortable feeling as a potential learning moment.
Right. And becoming more conscious of things like justification, asking what's the evidence for this? What's the reasoning? Or considering audience, how would I explain this clearly to someone else? Those are powerful learning strategies.
Applicable way beyond science class.
Absolutely. It pushes you to engage more deeply, ask better questions, weigh evidence more carefully, consider different perspectives.
It sounds like it transforms learning from just absorbing information
to actively constructing understanding. A much more engaged and probably more effective process.
Okay, this has been incredibly useful. Let's try and distill the core takeaways for everyone listening.
Sure. So, key point 1. Your beliefs about knowledge, your personal epistemology, they aren't fixed. They evolve, driven by things like doubt, dissonance, and your own effort, that epistemic volition.
And point 2, these beliefs really matter for learning. They influence how you engage, especially in areas like science where understanding the process of knowing is crucial.
Right, and meaningful learning, the deep stuff, happens when you see those epistemic ideas, justification, generality, audience, nature of knowledge as tools for your own sense-making, not just hoops to jump through.
Using them because they help you understand better.
Exactly.
Which brings us to our final thought, something for you, the listener, to consider. Take a moment to think about your own epistemic toolkit.
What are your underlying beliefs about what knowledge is? How do you think it's acquired or justified? How do those beliefs, maybe unconsciously, shape how you approach learning something new or complex?
And thinking about what we discussed today, concepts like justification, generality, considering your audience, seeking mechanistic explanations, are there any leverage points, as Berland put it?
Yeah, are there specific aspects of knowing and knowledge building you could consciously focus on to maybe deepen your engagement, make your learning more meaningful, more robust in whatever field interests you?
It's an invitation to examine your own process of knowing and see where you might level up your learning game. Thanks for joining us for this deep dive.